It's time to start working on the fuel system for my 4x4 diesel swap project, specifically switching the gas fuel tank over to work with diesel. Today's video is going to be a little bit different. I myself had a difficult time finding all this information, so the purpose of today's video is going to be to consolidate the information on how to do this into one place. I'm going to try and be thorough so that no matter what diesel swap you're doing, this information will help you make the decisions for your particular swap. Because of the length of the video, I am going to add a bunch of chapters, so if you're looking for a particular piece of information, just look down below and scroll over the progress bar and you can find where that information is in the video. The objective is not to have you follow along with exactly what I'm doing or to claim that what I'm doing is the best way of doing it. The objective is to give you enough information that you understand why I made the decisions I did and so that you can make an informed decision for your swap. So let's get into it. Upon inspecting the diesel fuel assembly, it is clear that there's a few features on it that I will not be able to copy over to the gas assembly. There's a large fuel cup as well as a float valve that both help to prevent air from being picked up into the diesel system. If you're swapping a diesel into a vehicle that had a stock diesel option, then I would highly recommend picking up a stock diesel fuel tank or assembly to retain these features. But now the Explorer fuel pump assembly. It has a pump on it. So first off, this has a filter on it, but it's a much finer filter than this one. So that is not a filter that I would want to use with the Cummins. Second off, it has a fuel pump on it. This Cummins one does not have a fuel pump on it. Where's the fuel pump for the Cummins, you might ask? Well, let's go take a look. The fuel pump on the Cummins is this big guy. This thing puts out tens of thousands of PSI, and it has to because each one of these goes directly into a cylinder. It's directly injected. And if you want to inject fuel into the cylinder, you have to overcome the insane combustion pressures that are already happening in that cylinder. So this is the main fuel pump for the Cummins. But if you ever looked at a pump curve, you would know that typically incredibly high pressure pumps can't necessarily pull a lot of volume. You're kind of sacrificing pressure for volume. So this actually needs a second pump just to feed it fuel that's a low pressure but relatively high volume pump. What this uses is the lift pump. Lift pump takes the place of the electric fuel pump on the Explorer. Rather than using an electric fuel pump to push fuel up to the engine, it uses a lift pump to suck fuel to the engine. And since it's such low pressure, it can get away with sucking it. If it were higher pressure, then if you tried to suck the fuel that whole way, you just start evaporating the fuel. So this is a very low pressure but relatively high volume pump that feeds the main pump, which is the main attraction on this diesel engine, the P pump. Most of the fuel filtration happens here. Rather than having a fuel filter sitting on the frame rails, you wouldn't want a filter on your frame rails with just a lift pump because this pump would have to overcome the pressure drop through that filter, which means this would have to be a higher pressure pump, which means that it would be dropping the pressure on the line and risk boiling it. All of this long-winded explanation is just to say, I don't need this pump. And I don't need this sock because it's too fine of a filter. And what that means is in order to make this fuel assembly work, the easiest way to do it would be to just drop a fuel line from here to the bottom of the tank in place of this pump. It would be nice if I could get a really coarse filter like this on it, but as of yet, I haven't thought of a way to do that. If you have any ideas, let me know in the comments. It would be really nice to get this whole cup set up with the float valve and everything, but I can't think of a way to easily and cheaply get something like that to work on this. I did take a look in the Explorer fuel tank, and you can see there is a little bit of a swirl chamber, a little bit of a sump area in that fuel tank. I'll put a picture on screen now. And so I think I will be okay just doing this. This would 100% be okay for any on-road application. You would never notice the difference. My only concern with doing something like this is that it's an off-road application. And in an off-road application, you can get your car to really crazy angles. And if the car is at a crazy angle, if I have a pickup tube here and I get it at a crazy angle, the fluid will move away from the pickup tube. I'm worried that at those crazy angles, I might actually pick up some air in this if my fuel level were low in the tank or whatever. Some options that exist are some sort of fuel air separator, like either a fast system or an air dog system. I could do something like that, but frankly, all of the ones I found from them are the combination where it has the filter, pump, air separator all in one. And those are expensive, and I really don't need to go that crazy right now. If I were trying to up the horsepower of this engine, then that might be a good way to go. But for right now, that's a pretty expensive solution. I can always install it later because it just needs mounted to the frame rails somewhere. All right, I'm gonna start taking this apart, but one thing I definitely need to keep is this. This is the fuel level sending unit, or whatever you want to call it. It measures the fuel level in your tank. And the way it does this, it's got this little float on it. As the level of fluid in the tank goes up, it lifts up this float. And that is measured through the sensor. Now, I want to make sure that I keep this sensor intact. So I whipped out my multimeter to check this, and I thought I'd bring you along with me and show you how to test these if you ever need to. So this, what I expected to see was a potentiometer. Okay, the way a potentiometer works, so you have one line going in, let's call that one minus, and then you have a resistor, that's the symbol for a resistor, and then another line going out, let's call that plus, and then you have a third wire. It comes in here, and this is your signal wire. So 3 wires. The way that a resistor works is it's basically just a big bundle of wires, and you get these wires so long by bundling them up so much that they have a certain resistance. And the amount of length of wire that you have in that resistor determines how much resistance is there. Now there's obviously lots of other ways to do it, but that's a really basic idea of a resistor. So if I have this resistor and it has 300 windings, and then this resistor which has 500 windings, and they're the same material, this one's going to have, why did I pick hard numbers here? 2/5, this one's going to have 40% more resistance than this one. So what you do here is you have this little wiper arm that's connected to this resistor, and that wiper arm can actually sweep. It can move across the resistor, and as it moves from this spot in the resistor, there might be 100 coils. When it moves to this spot, now there's 200. When it moves to this spot, now there's 300 coils. That's a variable resistance depending on how much that arm is moved. So as this float would swing up and down, it would increase or decrease its resistance depending on what spot on this resistor the wiper arm is actually contacting. That's a potentiometer. That's what I expected to see. I only see 3 wires here, which to me implies that it's a rheostat. It's this same thing, but you just remove this wire. And then that way, you just have minus there, and then your plus wire is your signal wire. It goes through and it reads the resistance that way, no need for a third wire. This is probably a rheostat, and it's probably one wire that's the signal wire going into this, and then it's grounding through this metal body. Let's pull out the multimeter and check it, and while we're at it, let's test it and see if it's any good. I'm just going to stick the common lead, the ground lead, on the body, wherever, it doesn't matter, and then I'm going to take this sensor wire and stick it here. As I sweep it, I'm getting a lot of out of limit. I didn't really expect to see that. At first I thought it was my multimeter being cheap, but this is interesting. This is giving me really weird readings. I'm actually going to go in and clean this off and see if maybe it does have some gunk on it. Let me pull the sensor apart real quick, or at least just spray it out. Don't stab your hand. Don't break the clip. There she is. All right, apparently I'm out of electronic parts cleaner. I could have swore I had some. So I just have this alcohol-based surface cleaner. That's what I'm going to use. It'll be fine. Give it a light scuff, very light. Like I was saying earlier, there is a wiper arm there. So hopefully you can see inside that board, there's a bunch of segments. This is the resistor that I was talking about. Okay, we got that cleaned out. Let's throw the backing plate back on and see if it acts any different. It's grounded on that plate. Grab the sensor wire there. 16 ohms. 20. Ah, there we go. Okay, now I'm getting a nice sweeping motion. I'm not getting any overloads as I'm moving this up and down. That's good, that's what I wanted to see. So I get a smooth sweep from 15 to, I guess, 160 ohms. That is what I wanted to see out of this sensor. A smooth sweep from 15 to 161 ohms with no out of limits anywhere in between. That's what you want to see to know that this is a good sensor. Now, I'm not necessarily saying that me going through and cleaning this actually fixed anything. What I'm assuming happened is that this was all dried up because it had been sitting in the car so long. And if I had just used this and filled the tank with fuel, it probably would have washed this out and it probably would have worked fine. But now I know for sure that this thing works because I've seen it work. And additionally, I know that I do not need these two wires. So with this one wire going to this sensor, that's all I need to make this work. Let me get this reassembled and let's pull out these wires because now I know I don't need them. There's the wiring delete for the fuel pump. I heat shrinked this power and ground wire and then wrapped it in electrical tape. I really don't want this to short out. That's gone. Now my two wires are this gray wire and the yellow wire. The gray wire is grounded to the chassis of this. The yellow wire is the signal wire. I should just be able to plug this back in and the fuel gauge will just work in the car. What I'll try and do later is actually pull the pins out of the other side of this connector just to make sure that that's not hanging there. The likelihood that it would ever short is very low, but if I somehow ever got the rear end of that Explorer underwater, it would. Not that I want to do that, but you know, just in case. Alright, this is what I figured out for my fuel pickup tube, or pickup straw as some people would call it. Now, I could have gotten fancy and turned a aluminum piece on the lathe, or I could have bought a nylon tube that they sell online in order to do this, or something like that, but if it's stupid and it works, then it ain't stupid. I just went with a single piece of fuel line, and then I made sure to cut the end at an angle so that it can't suck itself to the bottom of the tank. Other than that, you need to make sure that it can't float up, so hopefully this ring here will prevent this from floating in the tank and stopping picking up fuel. And some people think that you should keep this line far away from the return line because the return line can have air in it, so that's just another thing to keep in mind. Some people might not be as comfortable as I am with just having the return line that close. So what we did on this gas assembly was we figured out which wires were to connect the fuel level sender. We tested and made sure the fuel level sender worked so that we know that our gauge will work. We removed these power wires that go to the pump so that they won't short out. And then we replaced the fuel pump with just a straight tube in order to pick up diesel fluid. And now this gas assembly is good to be used in the diesel tank. That should be all we need. You could get a lot fancier and buy a sump that you screw to the bottom of the tank or anything else, but this is the simplest way, especially if you're going with a stock-ish power diesel for your swap. If I were going with a really high-powered diesel, I might consider going with an air dog setup and going with a sump in the bottom of the tank style setup rather than doing this. This is ready to go back into the Explorer. However, there's one final issue I want to talk about. I'm pretty sure these lines are galvanized steel, and galvanized steel is zinc coated steel, and diesel fuel has sulfur in it. Now when you mix zinc and sulfur, apparently you end up with zinc oxide, which is apparently a white powder that will sneak past your fuel filters, make it to your injection pump and your injectors, and cause damage to them. So you don't want to mix galvanized steel with diesel fuel. However, this is only a very minor amount of galvanized steel. It's not like the entire tank itself is galvanized. And also, modern day diesel fuels are low sulfur fuels. I think that I'm going to be okay with these lines. But frankly, I don't know for sure. I just wanted to bring it up in case A, somebody in the comments section knows a little bit more about this than I do and they can help explain it, or B, so that you can keep this in mind when you're doing your build. I am under the impression that most people who do this do it the way I have done it and do not worry about this. So it is probably fine, but I would be remiss not to mention it. So there you go. There could be an issue with these being galvanized. Let me know in the comments. Other than that, it's ready to go back in the tank. Now what I need to do is clean out this fuel tank. So I think a lot of people probably overthink this. They think that if you get any gasoline at all in your diesel system that it's going to cause a problem. It really won't. In fact, I saw someone on a forum claiming that they had read in Cummins documentation that you can run something like up to 10% gasoline in their 12 valves and it'll run just fine. I don't know if that's true. I wasn't actually able to find that documentation to verify it, but a tiny bit of gasoline isn't going to make a difference. The concern with having a little bit of gasoline in here is that it doesn't have the same lubricity as diesel, and so you don't want to lower the lubricity of your fuel. That can cause damage to your engine. But even just pouring this tank out, the amount of gasoline left in this tank is going to be a few ounces at most. A few ounces diluted in a 20-gallon tank or a 10-gallon tank, that's not going to change the properties of the diesel fuel in any measurable way. It's fine. So my biggest concern here is that I want to make sure I get the gas dumped out so that there isn't a large amount in here. And then what I'm going to do is I'm going to take a little bit of diesel fuel and fill it back up with the diesel fuel just to swish it around and rinse it out because my tank has some crap in the bottom of it. But if you have a clean tank, all you really need to do here is dump the gas out, dump all the fuel out of your lines, and then fill it up with diesel, and it should be fine. I figured out what all that cardboard looking or sawdust looking stuff in the fuel tank was. It was the bees. It's always the bees. Good thing I tried to rinse this out. Remember, if you're gonna rinse it out, rinse it with diesel. Do not rinse it with water, rinse it with diesel. Also, another quick note, you saw me trying to dump this out through the fill tube and through the vent hose and stuff. That didn't really work at all. The way the fill tube is it sticks down in there. You can't really empty it that way. I had to empty it through that hole in the top, so just so you're aware, it doesn't really work to empty it through the fill hole, which is good. Means if you roll over, it's less likely to leak everywhere, I guess. All right, I've got the fuel pump into the Explorer's tank, and now the final thing we need to discuss real quick is vent valves. As you add fluid to the tank or remove fluid from the tank, air has to either come in or go out in order to replace the fluid that's been removed. If your tank isn't vented, then your pumps will have a really hard time pulling fuel out of it, and you'll also have a hard time at the gas pump as well. So you need to have a vent. In my case, the stock Ford tank actually has a vent, and it's even a rollover vent, meaning that this will let air in and out, or vapors, but if the vehicle were to roll over, it will not let fuel come out. So that is a safety feature so that it doesn't just pour diesel out if you roll over. I think I'll be fine with this stock rollover valve for venting the tank. Other options are I'm also going to try to use a diesel fuel cap and diesel pickup on this. Some of the diesel caps are vented as well. Now that's not going to help while you're filling the tank, but it will help when you're pulling fuel out. So just something to keep in mind, your tank needs to be vented, and it is very good to have a liquid check valve in case of a rollover so that fuel can't pour out if it does roll over. All right, that should be job done. Let me know if you have any questions in the comments. If I didn't cover anything here, then one really good place to go for information would be 4btswaps.com. That's where I get a lot of my information, and they have really good people on that forum that cover all of the specific swaps in really great detail. I'd recommend searching through that forum. Thanks for hanging out with me in my garage today, and I hope you learned something. I hope this was helpful for your swap. Please subscribe and stick around, and I hope to see you next time.